All right, should be asking everybody if the recording's okay. I am joining you from the University of West England in Bristol because I've been teaching R since 9 o'clock this morning. And to staff and students here, which has been fantastic, but if I lose my voice in the next hour, that's why. All right, is everything, well, yeah, transcription. Thank you for requesting the transcription. There we go. Okay, that should be on now. All right, but because I'm at UE, I'm on like a tiny laptop computer, which is not my normal laptop computer, which died last week. So if I'm a little bit chaotic, it's because the screen is small and there's just so many things on the screen. I'm gonna put participants away. I'll keep the chat up and I will attempt to make this smaller. Why won't it get smaller? I don't know. Oh, well, okay. So that window's never gonna get smaller, but you guys can't see that window. Okay, so we're going to start out, type stuff in the chat if you need to stop me, or if I'm ignoring you in the chat, just turn your audio on and yell. So hopefully everybody's got the intro to our book link. I'm going to pop it into the chat. We're going to do a very quick review of chapter 1 for people who didn't catch up last week or didn't get a chance to catch up from the video last week. The recording is in chapter 1. Passcode's always going to be Coding Club 22 exclamation point. But what we're going to do is start up our studio.
Here's what I found.
No, stop talking. Watch. Okay. Get that full screen. Wait a second. Why is it being slow? All right. So we're going to first use, if you were with us last week, you can follow along and make a sort of a new demo package, call it demo package 2. If you weren't with us last week and you didn't get a chance to catch up, follow along. And this should get you to the place where we're going to start this week. So we're going to use a function from use this called create package. And the path is going to be where you want to save your package. I keep everything related to R inside my rproj folder. I'm going to stick this particular one on 1 second. Okay, that's fine. I'll just put it in the rproj folder. So, and then we need to give your package a name. So the name that we're going to use is demo pkg, demo package. So what this is going to do is generate a new demo package. Oh, no, there is, I swore I just looked at that and thought there is no demo package, but there is. That's just a test one I've been using. So escape out of this, redo that. Okay. It'll just create one because you won't have one with the same name. It should open it up in a new RStudio window. You can close the old one at this point. Full screen this. All right, so you should be able to see in the upper right corner here, the project you're in is called demo package. You'll have a few default files. One of them is a description file. So if we click on that, what we want to do is put a description of what's our package up to. So data and analyses from Brian 2002. Actually, I think it's 2004. We're gonna, so change our title. We're gonna add a date here. What's today's date? 2022, October 12th. And we're going to update the author to your actual name, your email address. But if you want to, in the book here, under edit the description file, it gives you, if you have multiple authors, how you might format that. Or I'm just going to copy this. What you can do is sort out the author here. At least one person needs to have the CRE role. This is the creator role. This is the person who gets emailed when something goes wrong with the package. We have a description of what the paragraph does, so we're going to edit that. Demo for Coding Club. And I'm going to save this description file. The next thing that we did last week when starting up was to choose a license. So we're going to use, and this is from the use this package again. So type use this, 2 colons, use, I'm going to use the CC BY license. So just tab autocomplete CC BY license. What that's going to do is update this file to put the correct license code and creates a license file in your package. So save that. That's basically all we need to do here. We're going to go now into the build tab in the upper right here and double check that everything worked out okay, that we don't have typos in our description file. So click check. It's going to run some functions from DevTools. This is why I'd ask that you install DevTools and use this before. And I've messed it up somehow. What has gone wrong? Malformed authors field. I've messed up something in here. So what's going on here? Oh, I started the parentheses for person. This end parenthesis is just for the org ID. Needs another parenthesis. That's why we have to check. That's the most common malformed something that's going on with the description. So if we do some checks, hopefully everything works out okay. Okay. Don't know why it's taking so long. All right. So we've got 0 errors, 0 warnings, 0 notes. Hopefully you do too, which means where in the book can we find the author's code? I'll pop you into the closest edit the description file. So I'll put that link in the chat. So the C means we're going to concatenate 2 authors here. But if you just want the one person, you can copy from here up to that last comma. And that's the structure for one person. Right, switch back to here. Okay, so now that we've edited the description file minimally, we can install our package. So just click this install button. And it's going to build your package, restart R down here, and then it will give you the library demo package. It's going to load your package using the library function. Really, the only thing you can do at this point is test this with the citation function. So citation, and in quotes, demo package. And what you should see is an automatically generated citation with your author name here, date, name of your package, and the description. And it'll say our package version 0.0.0.9000. And then the BibTeX thing. We'll be able to customize this later, but we're now at the place where we were at the end of last week's class. So has anybody got questions about last week or what I just zoomed through? All right. So you can put it in the chat or talk out loud if you do have questions. Where does year come from? Year comes from, oh, so if you've got something that says like there isn't a date, you need to add the date row. That's not in the use this template description file. So add the date in, that will give you a date. All right. So we pop back into, Is there a way to put your GitHub link in the citation? There is. Later, I'll show you how to make a citation file that will contain more information, a DOI, so you can give your package a DOI or the GitHub link or any other info you want. But we won't do that today. All right, so what we're going to do today is add a data set to your package. So most of you are probably familiar with, sorry, there's things on top of everything here. Just back to our studio. There we go. Okay, so built-in data sets like Iris is probably one of the most used built-in data sets. So we're going to create a built-in data set that will be built into our package. It's something that you can use to demo functions. It's often really useful when you're creating a package that when you're writing the examples for your functions, you're going to need some data to run your functions on. And so you build in a data set that has the kind of characteristics that your functions need to run. And then it's available for all of your example code. But here it's kind of the main point of a study package is to be a way to share your data sets and your analyses. All right, back to the web. Okay, so what we need to do is set up raw data in a way that the package can use it, which isn't quite as simple as just like adding your CSV file or adding your Excel file. So we're going to add some data to this package from one of my PhD projects from 2004 that looks at attractiveness judgments of same-sex and other sex self-resembling faces. So yeah, I do face research and kind of from an evolutionary perspective, looking at kinship signals. So if there's a kinship signal in someone's face, how does that affect how you judge their attractiveness? So we're going to add a data set called self-res-at. So take this code. So make sure I'm going to pop this into the chat because we're going to be copying a lot of code from this page. You can type it in, but it's a little bit easier if you just copy it. So, oops. Let me make that a little bit bigger for class. So use data raw. That means we're going to add some raw data with this name. So copy that code. Pop it. Sorry, the transcript is on top of everything. Okay, so what we want to do is put this into the terminal. Clamp my terminal here, because it's code that we're only ever going to need to run once. You don't need to put it in a script. So when you run that, it's going to create a folder called data-raw, which you could have done yourself, but use this has so many useful functions so you don't have to remember all the things. Thanks, Lisa. Okay, so what this will do, you will see in your Files tab, there's now a data raw folder, and it will also open up a .r file. That is the code that we're going to create to prepare the data set. What it does is it assumes that you have a data set called self-res-at, and it gives you the code to set it up in your package. We don't yet have a data set called self-res-at, so I'm going to show you how to prepare it. So, yep, we'll go back to the raw data setup, creates that raw data. We've got this file. Now you need to download the actual raw data. You can download it from this OSF site. So we'll pop over to OSF. If you look down here, there's we're going to just download the attractiveness data. So DeBryan 2004 PRSLB_at. And oh no, this is just being overwhelmed. The OSF often gets overwhelmed. Oh, in the console. So yeah, Daniela, that is not terminal syntax. If you ever need to put something in the terminal, I'll definitely tell you. Otherwise, default is code will go into the console or into an R script. What is going on with this data set? It is not that big. Okay. Huh? Does anybody else? Okay. What is going on? There we are. Okay. So you can just download this code, this data, or yes, someone has already responded. The download code works. There's also in the, there are so many windows that you guys can't see. They're on top of everything right now. Back into adding data. So there's also some code down here to download the file. If you copy that, go back into RStudio. If you put that code also into the console, it'll just download the file for you and put it where it's supposed to go, which is inside data raw. We're gonna look in there, and there should be DeBryan 2004 PRSLB at CSV. So we've got the data set. You've downloaded the data, cannot open it in R. Do you mean like if you click on it, you can't open it? Because you don't need to yet. Ibtihaj, you are ahead of us. Wait a sec. The message that you've gotten about spec is correct. You should get that message. So what we're going to do now is read in the data set from our CSV file. Okay, so we're going to do that before they use this code. We're putting this into that self-res at.r script. So this will be code that you could run repeatedly. Like if the data file on the OSF updates, we can download it again, reprocess it. We're going to read the code in. So how we're going to do that is with this code here. We're going to use the read underscore CSV function from readr. So I'll copy that. Paste it there. Okay. So this bit, if you've not copied and pasted that, I would recommend when you're typing this, use autocomplete to be able to find that data set. So we're going to look for it in the data-raw folder, hit tab. And then hit tab again, and it'll show you all the files in the data raw folder. And make sure that you've got exactly the right data file. We'll run this code. So you want to highlight all of that, hit Command Enter or Control Enter if you're on a PC. It's going to run the code, and read underscore CSV will give you a little bit of information about the data file. So here it tells us it's got 108 rows, 16 columns. The columns called ID, sex, eth group, and birth order are character columns. And age, mnon, fnon, mself, fself, group size, and some other stuff, they're all doubles. DBL is a type of numeric data that like can have decimal places, but doesn't necessarily have them. So this makes sense based on what I know about the data set. It says you can use spec to retrieve the full column specification for the data set. We'll do that in a second. But if you look in your environment tab and then click on self-res, it'll show it to you in a kind of a tabular format that you're probably more familiar with, like from Excel. Just have a quick look at the data like this to see, does it look like what we expect? I'm going to tell you, yes, it does look like what we expect. These all look sensible to me. You, when you're loading your own data, will have an idea of whether or not your data look like what you expect. But we might want to set some of these categorical factors as factors. Read CSV, or if you use read.csv, they're going to read in as characters. So they're just character columns. They're not treated like factors. And if you want to read in data with the factors, and then you can also set the order that the factors will display in a plot or something. Like if we wanted some specific order, have male before female or vice versa. Say why I use read the underscore CSV so that we can do what I'm just going to show you how to do. So remember down here, it said use spec to retrieve the full column specification. So I'm going to type, and spec comes from the readr package. Since we haven't actually loaded that library, I'm going to type readr space or colon spec self res at. So this gives me the column specification. So every column, is it a character column or a double column? And now you can fix things that go wrong or specify factors and the ordering of the levels, which can be really important. So like for birth order, the alphabetic ordering of the birth orders doesn't make any sense. We want to switch that order. So I'm going to copy all of this. And let me just make sure I'm matching what I tell you to do in here. So you'll see this, copy all this. We're going to assign it to a variable called CT. It's like column type. So this is what we're going to do. Actually, this before we read it in. CT is this column specification. It's going to use a whole bunch of functions from readr. So let's actually just load readr at the beginning. Okay, so what we want, sex shouldn't be a character column. This should actually be a factor. So we'll change that to col factor, and we'll set the levels equal to, we can have a quick look at the data. It looks like they're male and female. So I'll set the levels here to, actually, let's match what I told you to do. We'll do female first, then male. And we've got F group, which is also a factor. And it's, let's not set the levels, we'll just let them stay alphabetic. And so we're into birth order. So the levels for birth order are only born, like only firstborn, middleborn, or lastborn. They would alphabetize as firstborn, middleborn, no, firstborn, lastborn, middleborn only, which doesn't make any sense. So we'll give them this, these levels. So hop back in here. So we're going to change birth order to a factor type and set the levels to those levels in order. So now that we have a few of our columns redefined, so they're not the default character column type, they're factor types and with a specified order, we can define the CT variable. And then, like in here, we set the col types argument to CT. So when we're reading in our data, col types equals CT. So now when we read in the data, we don't get that warning message anymore about column types because we've told it for sure what the column type should be. And then when we look at our self-res data here, we can see that like birth order is a factor with these specific levels, and sex and eth group are factor types. In this way, you can make sure that your data set has the kind of structure that you want before you save it. And then when other people use your data set from your package, those columns will be factor types with the level ordering that you want, rather than relying on other people to read it in from a CSV file or from an Excel file. Okay, so we're putting, again, all of this in this particular script. We're setting up the column types. We're going to read in the data. And now that we're happy that our data are in the right form, we can use the default function that used this put into the script. So that was already in our script. It's just the use data function. You put the name of the data file as the first argument, and this is the name that is going to be used in your package. So just like you can type iris into the console and it shows you the iris data file from the base R package, when you have your demo package loaded, if you type self-res at, you'll get this data set. So make sure it has the same name that you want to use in your package. You can't rename it after this. And we're going to set overwrite to true. So if we change our mind about anything here and we run the script, it'll update and fix our data set. So you can run all of this from start to finish. All right, so Tom has gotten, oh, let's see, force palette, what is going on there? Expected single logical value. I'm not sure what's going on with that. So the CT definition, if you can pop into the chapter, if you just want to copy exactly this, that should fix your CT definition. All right, and is the palette error? Oh, can people not direct message me because like it goes past so fast that I can't find it back? All I can see is that somebody direct messaged me, and then anything I type in the message goes just to them now until I fix that. So, all right. All right, so error in force palette, argument palette is missing with no default. I'm not even sure where that would come from. Does that happen after you load the data or when you use the use data function? CT cows. Have you loaded readr? Have you run this library readr yet? It could be that cows, All right, remove, like just comment out the entire CT thing. So for you, and we'll try to troubleshoot this later, but comment all of that out and just do CT is cows. That's going to make everything default. And then that should work for you. I'm going to not do that. If you do that, that hopefully will work, and then we'll troubleshoot it later. Thanks, Paul. So if you got an error about expected single logical value, it might be that you set levels to either nothing or just C, or you didn't put enough levels in. So double check that. Basically go back to the chapter, copy this bit exactly, and hopefully that will work. Okay, let me actually rerun this to make sure I've got all of this run in the way I expected. So this last line, the use this, adds the data to your package, the actual self-res at data. So what we're going to be able to see in our files, oh, sorry, moving stuff around, chat's on top of it. Okay, so now inside of demo package in the files tab, you'll see a new folder called data. You should never put anything in this folder. The data that you're going to add to the package, you put it in the data raw folder, and then you write a script to process the data, load it as a data frame, and then you use the use data function to save the data frame as a data object for your package. It's going to put a .rda object in here. But again, don't touch those. Just let R do its thing with that. All right. So double check that you do have that. If you don't, let me know and we'll try to debug it. But that is adding a data set. The next thing that we need to do is document this data set. Okay, so is everybody relatively caught up there? So we've got this script that we don't need to run again unless something changes about our data. We decide that we want to change the factor levels or do some more processing on the data, we can add it to the script. But if not, this is just there documenting how did we go from raw data to the data set that's going to be included in the package. This the raw data here inside data raw is not going to be part of your package, in that it won't be shared. If you share your package with other people, they won't get the raw data. They'll only get your process data. And we use this function to create the raw data, because that also tells R to ignore this file when we're building the package. It sets a few extra functions that are necessary that otherwise you'd have to do manually. So that's why I like to use the use this functions, because otherwise there's like 4 more steps I'd have to ask you to do. All right, so raw data is really, like if you load in raw data and then you filter out people who don't want their data shared, and then in your code here, before you add the data to your package, really people can't recover the data unless you're sharing your raw data on GitHub. So you'd have to specifically like go into your git ignore file. If you don't have GitHub set up, and we're not going to go through how you set up GitHub until later, but for those of you who already use GitHub, you might want to put data raw here, and then you wouldn't be sharing your raw data folder on GitHub, which might have some reproducibility problems for you. But if you're not allowed to share your raw data, then you can handle that bit yourself. I'm gonna not do that. Otherwise, it does share the raw data file in your Git. So if you're doing package development only on your own computer and you're not sharing your package development files with other people, it's not going to include them in the package. So you can do package development on your computer, create the package files, and then you could send those to other people and not share them on GitHub and not share all of your code on GitHub. So if you send the package files don't contain the raw data, but your code project contains the raw data. So you can, if you choose to share that, you've shared that, that's separate from the package files. And you can include as many data frames in a package as you want. Part of your homework is to add another, there's one other data frame from this project about averageness judgments. And it's to add that, to use this exact same method, but instead of, we'll scroll back up here. So instead of doing use data self-res at, we're going to call it self-res AVG. And then you're just going to do this whole process for a second data set. All right, so we should get to documentation now. So data always needs to be documented. And it's going to be documented in an R script that's inside of the R folder of your package. The quick way to make a new R script in the R folder is to use the use this function called use R. And then we're going to, in quotes, say the name of the data file. So let's copy that. And put this is, most of the use this functions go into the console. So use this, like we'll create some files and stuff. You don't want to put it in a script. You don't want to keep doing it over and over again. This is a one-off, the first time we need to make the self-res at file. And it creates it. Now, if you really want, you can just create a .r file the normal way with new file, R script, and then save it into the R directory with the name self_res_at.r. It is not required, but I feel like it's good practice and it keeps things pretty straight if the files in the R folder are where you're going to put all your code. But they're also, they generate the documentation for your functions and for your data files. And if the code that creates that documentation is in a file that has the same name as the object it's documenting, that makes it really straightforward to go find. If you forget, like, where did I document the data frame called self-res at? It's obviously going to be in a file in your R folder called self-res at.r, and that's good. Then you'll be able to find it. if you start giving them esoteric names, nothing bad will happen, but you won't be able to find where you did something once your projects get complex enough. All right, so we're going to put our documentation in here. What does the documentation look like? Let's go back into the chapter 2.2. I give you a template for this. So just copy this template and paste it in here. So what do we need to change? You'll probably need to have the self-res at file up, so like in the viewer, so you can see what's going on with it. All right, and then we go back in here. Oh, this is a confusing thing. These both have the same name now. This is the file that prepares your data set, and it's inside the data raw folder. So let's close it. What we want to do is work on the file that's inside the R directory. So let's give it a title. For consistency, let's do what we say here. So it's going to be attractiveness of self-resembling faces. It should have a full stop at the end. I don't know why. They like that. And then we need a description of the data set. You put here, this can be as long as you want. You could put a whole paragraph in, you could put several paragraphs in, but we'll go for a relatively short one here. So attractiveness judgments of same-sex and other sex self-resembling faces from DeBryan 2004. And then there's this format. So they always start with the format of how many rows, how many columns. So you can just have a quick look here of I've got to move things again. Nope, moving the wrong thing. Okay, so we've got 108 rows, 16 columns. So 108, 16. And then we're going to skip this describey bit, but here's where we're going to describe each of the columns. Say the name of the column and then a text description of what it is. This is the kind of tedious part. And I'll show you a way to generate the structure using code. And there's an appendix kind of that has a bigger function that we can use to generate these if you have a whole bunch of them too. But let's skip the describe bit right now. And right here, we've got your data URL. So inside the curly brackets, we're gonna put what's the source of your data? Like what web page did you go to get the data? So we can just copy in the OSF link here. You can delete this whole line if your data doesn't have a particular source. You can also have the source not be a URL. It could just be a bit of text. It could be the DOI of the paper. It could be a text citation. But a URL is probably the best way to go. And then the last thing we need is the data name. So that needs to be self-res add. It'll be the same name as the actual data object here. Okay, so this is going to generate automatic documentation for our data set. But let's get this describe in here set up. Our table actually, it's got 16 variables. So you can go in here, copy this bit 8 times, paste it in, you'll have 16 rows, and then just manually edit everything. It's a little bit tedious. So what I've shown you in the chapter is to use this code, get the names of self-res add. So first we grab all the names. There we go. Let's just put that into the console. That gives you all the names, but we want it in a format where we can kind of code with it. So one of my favorite functions, we're going to pipe this to dput. So dput gives you the syntax that you need to create an object. I've got this list of IDs, but I don't want to copy that get rid of the 1, 5, 9, and 13, add the commas in, fix it all up. So if I just pipe it to dput, it gives me code that I can copy and paste into a script. So I'm going to copy that. Where I'm going to paste it, actually, I like to do this inside of, oh goodness, so much stuff on top of other stuff. Here we go. Back into data raw, the self-res are where we prepared the data set itself. I'm going to put this code at the end of that. So going to set up a vector of all the column names. I'll put this. This is just me being picky about format. Oh, cat collapse. Yeah, dput is just a real time saver. So you don't have to type in all that stuff. So if you get it set up kind of like this, and then we're going to define each of these columns. We're going to assign this to a variable, just call it vars. And then here are all the things. What we could do is go into our script and get back to script. Like what you would do with your own data set. There's equals subject ID, sex equals, and then this is tedious and you don't want to have to do this with this one. So I've written it all out for you. It's in the chapter. So just grab this bit, copy it. Pop it in there. Okay, so now we've got a named vector where ID is the participant unique ID, sex is sex of the participant, and you can give the levels. That's often helpful. And this will be basically your codebook documentation. So if somebody's looking at the data set and they want to figure out what is it in the M non column that's not obvious. It's the mean number of times the other group members chose the male faces more attractive. I would have to explain this entire study to you to make that make sense. We're going to not worry about it right now. Oh, sorry. Yeah. So if people don't have the this pipe, if you have lower than 4.1 for your R version, you won't have the base pipe. Therefore, if you want to, you can use the Magritter library, or if you're loading dplyr, dplyr also loads the Magritter pipe. So you load that, and then you can use this pipe instead, or you can just not pipe. So for those who are unfamiliar with piping, piping takes the results of one function and sends them to the next function. So what we were doing with like I'm gonna concatenate A and B here. So that gives us the vector of A and B. And then if I pipe that to dput, that gives me the code to create what I just typed. And if I've got the Magritter pipe, that'll work as well. But what you can also do is just not pipe it. You could do dput and then put this inside the dput parentheses, and that's equivalent. And not too bad, but when you've got a lot of stuff, I like piping better. The other thing you can do is assign this to a variable, like x equals that, and then dput x instead of piping. So there's a few alternatives to piping. You're going to see me pipe a lot though. Okay, so we've made this vars vector. It's got names that are the same names as our columns and in the same order, and it's got descriptions. And then I'm going to show you a little bit of code that we can use from the glue package that will format our description file. The description rows have curly brackets in them. So if anybody uses glue, normally you put all of your like strings that you want to replace inside curly brackets. but that doesn't work for this. So I have to redefine the opening and closing to use square brackets instead of curly. So that's what this code is. And it basically just creates that each row, the hash, the single quote, a tab, backslash item, curly brackets, the name of the column, and curly brackets, and then inside of curly brackets, the column description. So that's how they have to be formatted, and it'll just do that for you. So if you have your column names and descriptions in this format, then this code will, for any data set, format that in the way that you need for the description file. So I'm going to copy this to the clipboard and go back in here. So, and just put that here. So I've got VARs. So we're going to make the column names all the names from the VARs object. And the column descriptions are going to be all the VARs. Hit glue. It's going to pop it into the console. And then you can just go copy paste it from the console. Into your description file. So these two lines where it gives you description, just paste that. And now you've got all of your stuff described. You can totally just manually type all this in. I really hate doing stuff manually. So we've got every column described in this very specific format that needs to have the spaces exactly like this and the curly brackets exactly like this. We're going to save it. All this stuff is just, we've got this other file that tells us all the stuff that we need to do to prepare our data set. But once we've run it once, we can ignore that file. All right. So the main things that have happened here are we've created selfres@.rda inside the data folder. And inside of our R folder, we have selfres@.r, and it contains this description in this format. Once all that's saved, you can kind of close everything down here. And let me check okay. So the next thing we need to do, so this is our documentation for the data. We need to add the documentation to our package, like create, the help files that we see in our studio. We need to create that help file for our data package using the documentation file. And so the DevTools document function does that. Copy this, or you can type it in. DevTools document, just put that in the console. And that's going to update your package, its documentation. You're going to see this updating demo package documentation, loading demo package, and then writing selfres@.rd, which that's the file where the help file is contained. So that's written, that's good. And now we gotta load the package. So you can do DevTools load all, or you can run this from the build tab. You can just click install. Now let's restart the R session, demo package. So it's loaded demo package. And now you should be able to type self and then see selfres@ here. And that will load your data. Or you can use the data function, selfres@, and that should add it into your environment. Oh, I didn't clear the environment from before. Let's clear the environment and show that this adds it in. Because it's a data set inside of a package, when you load it this way, you'll see that its value is a promise. It's just like, I promise to give you this data once you need to use it. We're not going to load it until you need to use it because it might be really big. It's not really big. But once you click on it, then it'll show you how many observations, how many variables, and then you can open it up in the viewer. So that should be added to your package. All right. So we've got 5 minutes to fix that. This is what I was meaning to show you. You should be able to access the data now with these methods. You should also be able to see the documentation in the help pane. So if we go back here and do question mark self res at, you should have now a help documentation that has your title, your description, how do you use it? You just type it in, the format, and then each column's definition and the source, all formatted for you. If you don't have these things, then we've got to do a little bit of debugging. But this is basically, that's what I meant to teach you today. And the sort of further practice is add this averageness data set. And I've given you the definitions of all the columns in that data set. Or if you're working on your own package with your own data set, add some of your own data to your own package and work out the description file. I'm gonna turn off the recording now and then help people with their specific debugging problems. All right, has anybody got generic questions that aren't really debugging? All right, I'm gonna turn off the recording. Hope to see you all next week. All right. Sorry, something on top of the stop recording.